Hello Year 12 further mathematicians. We're just going to continue with the complex numbers chapter in the Further Pure book. So this is 1.3 complex conjugate, and the complex conjugate is used to help you divide complex numbers. So there's some notation I need to introduce to you. So as you should know that for complex numbers they tend to use the letter Z. And the general complex number would be a plus bi, where the a and b are real numbers. So that could be something like 3 plus 2i, minus 5 plus 6i, etc. New notation is this, z star. So z star is this title of today's lesson is called the complex conjugate. And the operation that you have to do for this is if I tell you that z is equal to a plus bi, then z star is a minus bi. You swap the sign of the imaginary part. And these two things come in pairs. So a complex number and its complex conjugate all come in pairs. For example, you had 3 plus 5i as the complex number, then 3 minus 5i is the complex conjugate pair. If you had 7i as the complex number, you might want to think of that as 0 plus 7i, then minus 7i is the complex conjugate. And finally, if you had negative 2 subtract root 3i, then negative 2 plus root 3i is the complex conjugate. And all you need to do is occasionally in an exam style question they'll use this notation, and you need to know that means complex conjugate, or just switch the sign of the imaginary part. But the second use of it is to help you divide complex numbers, which is what we're going to do in EG number 2. So EG number 2 is as follows. We've got 5 plus 4i over 2 subtract 3i needs to be in the form a plus bi. Now, this question should look relatively familiar to you, particularly if I replace the i's with root minus ones or square root. It will look very similar to a surds question, and in particular rationalizing the denominator in a surds question. Let me just illustrate that a little bit more. Now, I've replaced the root of the i's with root minus ones, the surd part. Now, obviously, up until this chapter, you would have done that because you didn't think root minus 1 was a thing. But if we treated this like a surds question, so that was like root 2 or something like that, then you should know the only good next step is to multiply by, the word again was using this, the conjugate of the denominator. 2 plus 3 root minus 1. 2 plus 3 root minus 1. And if you look to see what I've done there, switch the signs, that is the complex conjugate. So the method's exactly the same as if you had a surds question, but we call the thing you multiply by the complex conjugate. It has a name. So pick on this, 5 plus 4i, I'm not going to write it as root minus 1s, over 2 minus 3i, times by the complex conjugate of the denominator, and then expand the brackets like before. the reason why this works is we want it in the form a plus bi, which is just a real part and an imaginary part. We don't want a complex number on the denominator. It just doesn't. It doesn't make sense. So let's times the numerators. So we've got 10 plus 15i plus 8i plus 12i squared. The denominator, lots of things should cancel. I'll write it out in full first. You've got 4 plus 6i minus 6i minus 9i squared. Collect like terms and simplify. Remember, 12i squared is the same as minus 12. So it's minus 2 plus 23i. 6i, subtract 6i, disappears, and negative 9i squared is the same as plus 9. So that's over 13. And in order to make it look like what they want you to rewrite it as, a plus bi, just have to write it separately as two separate fractions, like so, and that would be it. So when you're asked to divide complex numbers, you have to do this, show these workings, which is called multiplying by the complex conjugate. Okay, and that's pretty much it. Now the questions I'd like you to try today are on page 7, exercise 1D. Go on to page 8 as well. And you're going to try question 3, part A and part C. Question 6. I'll give you a clue with this. Make Z the subject. Question 9. Question 11. Again, make Z the subject. And one more, let's try question 13. And that'll be it.